Welcome to Haltech Elite NSP Training Part 37. In this training tutorial, we're going to be focusing on our intake air and engine coolant temp corrections in our fuel delivery, how they're going to affect everything. We're also going to be taking a look at something called our bias correction table that's going to be influencing our fueling in our volumetric efficiency strategy as well. So we have a lot of things to discuss. Let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at two of the most basic correction factors we have in our fuel delivery within our Haltech system. That's going to be our air temp compensation as well as our coolant temp compensation. We'll break down what these mean here and just understanding another layer to this, looking at something called our coolant temp bias table, where we actually have a blending factor. We can enable this between air temp and coolant temp, and we'll talk about that towards the end of the tutorial of how to go in and work with it and why you might want to work with it. So the very first thing I want to talk about here is going to be the most basic fuel correction that we have, which is going to be our engine coolant temp fuel correction. We actually jump in here from our fuel tuning window into our window here called fuel correction. You'll find that you have fuel coolant temp correction table populated right here. There's also another table here, fuel air temp correction, and then we have our calculated air temp coolant temp bias table. Again, that's another topic towards the end of the tutorial. But right now, let's focus on the fuel temp correction table. This is the most basic correction table that we always have to have populated with some type of values in the table. The air temp correction table may or may not be something you actually have to populate depending, again, the options that we select in our navigation tree up here. We'll talk about that in a little bit. Let's jump back in here to our fuel coolant temp correction. Now this table here, we can see it's based on coolant temperature on our axes on the left, and on the top axis is going to be based on manifold pressure. This is the default breakpoints and table setup for all of the Haltech base files. And this is going to work pretty much for any engine. If you're finding that, just to give you an example, if you're finding under your fuel tuning that your fuel load right here is set to something like throttle position, you might want to consider then also setting your table up here based on throttle position, not manifold pressure. It's up to you. You can leave the parameter alone here for manifold pressure. That could also be suitable. So just depending on what you want to go and configure, if you want to go and stick to the same load units or load scaling as your main fuel table, you can bring that in here and set this to fuel load using your breakpoint. So if you click on the table here, we can see manifold pressure is our option. We can go ahead and select that to fuel load. So let's go ahead and cancel. And then obviously we'd have to change our breakpoints if it's throttle position based to something like 0, 20, 40, 60, 80, 100. Just give some breakpoints relative to the throttle position. But either way, this table is pretty good out of the box in terms of the configuration and the resolution and the breakpoints. Now what's the purpose of this table? So what we're to find is that this is going to be correcting and adding a percentage of fuel adjustment to the base injector pulse width that's coming either from, if we're injection time based, fuel flow rate strategy, or speed density, volumetric efficiency based, even mass airflow based. This will add to that base pulse width, the pulse width coming from the whatever's calculated, whatever's commanded from the table. So what we're gonna find is that we have something called a wall wetting effect that we're trying to overcome, and that's the purpose of this table here. So when we're spraying our fuel into a cold engine, the fuel's gonna spray out of the injector, it's gonna try to atomize. Now the air is cold, and what's going to happen is the fuel isn't going to spray and atomize the same as it would in hot air. We have another factor here where we have a film factor where the fuel, as it's spraying out because it doesn't atomize very well, it's going to adhere and stick to the intake valve and into the intake track on a port injection engine as we're trying to deliver the fuel. And when the engine is cold, it's going to have more of a sticky type of a factor where the fuel is going to be sticking more than on a warm engine. On a warm engine, we'll have more of that fuel getting into the engine itself and less sticking to the walls. There is some residual fuel that's going to still have a sticking to the wall and to the intake valve, but it's much, much less because the engine heats up, that phenomena starts to dissipate, and it's not as great. So what we're gonna find here is that this table is going to allow us to add a certain percentage increase in our injector pulse width to compensate for that fuel being stuck to the intake track into the intake valves. That's how you can think of this particular table. Now, when we're dealing with this, let's jump in here. Our main fuel table, whether it's going to be injection time based, fuel flow rate based, VE based, or even math based, the table that we're dealing with here, this is going to represent the fueling delivery to our engine on a warm engine. A warm engine, coolant temp wise, I consider to be anywhere between 160 to 220 degrees. Below that, the engine is warming up and it's coming up to operating temperature.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.